yeah, so we can record it and we'll put it in the drive. So if you want to get the drive. Cool. All right, welcome everyone. We'll just wait. People are still joining, so we'll wait till maybe 2 or 3, maybe 5 past, when people sort of stop joining. In the meanwhile, just get up RStudio if you've recently come in, and see if you can get this. We've got Varun and Daniel here, so they're from MDSS, and they'll be helping you if you got any questions.
Hey everyone. Yeah, shoot me a message and I'll send you a direct message back if you have any questions. And then if we get really stuck, we'll do a breakout room and then we'll figure out what's going on. Cool.
All right. Cool. All right, so it seems like most people have joined. So I guess we'll start the session off. So today we'll be working in RStudio, and we'll be learning some of the basics of R. So by the end of it, we'll be filtering through a data set, and you should be able to find some interesting sort of insights and things like that. And then in the next workshop, we'll go through some more sort of dealing with the data and making summary tables and stuff like that. And then we'll go on to graphing. So this will just be the basics. So if you haven't really done much R, this is an excellent place to start. So we'll start out with setting up the environment for R. And so if you go over into, if you've got it installed and your screen looks like this, you can just skip this part and I guess relax for a moment. But if you haven't installed R, that's all right. We'll quickly be showing you sort of how to get it working. And so in the next 5 minutes, we should have everyone set up and ready to go. So if you haven't got R, what you want to do is you want to download this file in the Google Drive. And so I'll paste the link in the chat right now. And so download this file, session1.rmd, and then go over to rstudio.cloud. And once you go to rstudio.cloud, you should see a login screen that looks like this. And so you can just click the login because you can log in from your Monash email. And so you click login, and so then you want to go log in with Google. And this will give you this thing. You just pick your Monash email and create an account. And there we go. So we'll have our workspace here. And then to get it to look like our RStudio screen, what we'll do is we'll go new project. You can name it whatever you like over here. And it'll take a few seconds to load. And then once that's loaded, we'll show you how to get the RMD file into this RStudio.cloud. So make sure you have downloaded the R Markdown file from the Google Drive. And then what we want to do is we want to click this upload button over here. And so we'll click upload, and then we'll choose the file. So just in downloads, double click on the download that you've just done, and then click OK. That will upload it into the cloud, and so you'll have it uploaded on this cloud machine that we're running R on. And then once you've done that, double click on this or single click on it, and it'll come up and it'll look like this. So I'll just give everyone a few seconds to get either it working on RStudio Cloud, or you could, if you've downloaded RStudio, you can do it on your computer. So maybe just give a thumbs up or just let me know in the chat if you're all set up and you're all ready to go. Or if anyone has any questions and is struggling to get it to look like this, then also please, let us know. But just wait a couple seconds. Oh, Nelson, I'm doing it. If you wanna send a message afterwards, I'll give you I'll post my email address. So if anyone has any questions.
Sorry, George. How did you open the session one .rmd? So I created a project in RStudio Cloud, but after that I don't know what to do.
Okay, so you click this button here that says upload.
Okay, upload.
And then you choose the RMD file that you've downloaded. And then you once you've uploaded that, it'll be here, it'll appear over here, and you just click on that once.
Okay, got it, yeah.
All right, cool.
Thank you.
Awesome. So the RMD file, you just go to that link and it'll be in the Google Drive. There, it'll just be session1.rmd. No worries. Awesome. Beautiful. Cool. All right, so I guess if everyone's set up and everyone's ready to go, then we can start with just some of the basics. So this is RStudio. So it's R is a programming language, and within R we have a development environment called RStudio. So this kind of goes on top of your R and it lets you write all sorts of extra sort of functionalities. It'll keep track of what you've saved. It's got a special spot for plots. It lets you run code line by line. So it's really quite useful if you want to, if you're going to spend some time developing R to get used to this environment. So over here we have, this is our code. So this is our RMD file that we're working on. Any code we run will appear in the console here. And over here we have something that has the plots. So files, you can see different files. You can see the plots that you make. You can manage packages. And over here, we'll see any variables we save. So once we start saving variables, they'll start appearing in here. So this is an RMD file that we have over here. And so we'll see little cells here. And so to execute a cell, you highlight it like this. And if you're on Windows, you press Control Enter. And if you're on Mac, you press Command Enter, I believe. So R supports a bunch of mathematical operations. And so one of the most simple ways to use R is like a calculator. So you notice if we do write in the code 1 plus 2 and we run it with Control Enter, we will get 3. And so you can run any of your own code. So in the
Yeah.
okay.
Oh, I'm sorry. I'm
No,
just
that's right.
facing an error. I'm opening the session 1 RMD, but it's showing blank. There's nothing in the file over there.
Okay, that's right. That seems to be a problem that we've had before. And so if you go File, New File, and then you go R notebook like that,
Okay.
then you do that. And then on the drive, we have a text file. So just this text file here. If you copy and paste that text into the new notebook, it'll be just as good as uploading it otherwise.
All right, thank you.
Cool. So, and yeah, upload, if you're using RStudio Cloud, then upload will be over here. But if you're using it on Windows, then you just go File, Open File. Cool. So over here, we can use it as, so within these cells, so these are 3 backticks and then an R. And this shows that it's code, and here is just text. So RMD files let us mix text and code together. So we've got the code in here, which is 1 plus 2. We press Control Enter, and it runs and gives us a 3. So if you want to run that code now, then just run the 1 plus 2, and you should see that it works it out for you. And you'll be able to do it here as well. So you can run some very basic calculations in R. So this is 4 times 40 minus 10, 150. Beautiful. So if everyone's run that code, we'll move on to saving variables. So we can do calculations in R, but we're going to want to save them for later. So R has variables here. And so to save something to a variable, we use this operator to assign it. And so in other languages, we might use an equal sign, but here we use the arrow. And so they're stored until we restart R, basically, or unless we clear them. And so it'll just memorize things. So say we measure a circle, and its radius is 40. We can say save the radius here as 40. And so Control Enter to run this. And you'll see over here that our radius is saved as 40. And then if we wanted to show our radius over here, we just run radius. So it just prints out the last thing that you run. So if we run radius here, it'll just show us, oh, sorry. It'll just show us 40 over there. So we can save variables like that. All right. And so one of the reasons we're going to save variables is so that we can use them in later calculations. So in this example, we've saved our radius as 40, and we are going to calculate the area of the circle. So if you get that error, are variables typed? R uses something called duck typing, I believe. So they are typed, but you don't have to declare the type. It'll infer the type. So here, if we're getting the error over here, so make sure you run this one first. So highlight this one, press Control Enter. That'll run it. And if you've got your radius 40 in here, and then go over to radius, press Control Enter, and you'll get 40 printed there. So that should work. If you're still having issues, then message Daniel or Varun, and they'll help you out. Cool. So we've saved that there as 40. And so now we want to do a calculation. So we have a pre-built, so R comes with lots of sort of pre-built-in functions and variables. And so here we want to run circumference. So to figure out the circumference of a circle, we're just going to have radius multiplied by pi multiplied by 2. And so you highlight that, you press Control Enter, and you see here it'll work out our circumference and it'll save it. So it'll do that calculation and it'll save it. And then if we want to see what the circumference is, Control Enter, and here it is. So we've got some basic calculations here that we can do now. So yeah, if you want to practice these, you can copy these entire sections. So you just go this, Control C and Control V, and you'll get the copy. And so you can edit it, like, for example, if you want to work out the area now, you can do is this pi r squared. So we do that and we square this times by that times by pi. And if we run that, oh, there's a typo. There we go. And then the area will be over here. And then area. Cool. So if everyone's up to here, then we can keep moving. And so those are numeric variables, but we also sometimes want to save strings. So strings are just a collection of characters. So it'll store things like names, places, or really anything that's not expressed, or any sort of, it'll save a collection of characters. So things that aren't added, like you can't add together and stuff like that. So to tell R that it's a string, we include quotation marks. Otherwise, it'll be considered a variable. And so we use single or double. It doesn't matter as long as they're the same on both sides to represent. So it can represent the names of categories in sort of data frames once we get onto that. And so we save them in much the same way that we can save integers. So my name's Josh, and it'll save my name as Josh. So another type of data that we can store in R would be Booleans. And so Booleans are true or false. It's just, so we can save them directly like this. So we're just calling this is false. And that'll be saved as false over there. But Booleans are a lot more useful if we use them, for example, in comparison. So often we won't just declare like this, but a Boolean will be given as the result of us checking something or comparing something. So for example, my height, I'm going to save as 178 in the same way that we saved radius. So over here, my height is 178. And so now what this is going to do here is it's going to take my height and it's going to compare it with 120. And so if I'm taller than 120, then I can go on the park ride. Is there a shortcut? Yes, it is Control-Alt-I. And you will get that, I believe. Let me just check. Yeah, Control-Alt-I. So if my height is greater than 120, it'll give me true. Otherwise, it'll give me false. So that, and then we'll run this, and we'll see what is stored in my height. So we can see can ride is true. So my height is taller than 120. And then Control Enter, and that is true. But say, for example, if people only 100 shorter than 120, say it's a child's ride, then we can do less than that. And that'll run there. And can ride is now false because, for example, I'm taller. I'm too tall to go on the ride. Cool. So as up to now. If everyone's all right, we'll just keep going. If anyone's behind, let me know in the chat. And otherwise, onto vectors. So it's all right to save just 1 or 2 variables, but R is about often when we have data, we'll have lots of data. And so it can be kind of ridiculous if you're creating hundreds of variables, say for each person or anything like that. So we're going to want to store collections of variables together. So we're going to introduce vectors. And so they'll save a collection of variables, and they can only be used to save data of the same type. So to create a vector, we're going to use this C function. And that'll take everything, all of its arguments, and put them into a vector for us. So it'll store them all in the same place, and it'll allow us to reference them with a single variable. So we're going to create a vector here. Can you describe a list and a set as well? That's not in the workshop today, unfortunately. If you would like more information or you have any questions afterwards, I'm happy to answer them. I can explain that when we're done, but unfortunately that's not in here today. So we've got a collection of numbers here, and we want to save them all together in one spot. And so these strings can have, no, they can't have a mix. So you can either have numbers, or you can have strings, or you can have booleans, or you can have any other type of data, but they all have to be the same. No more than 2 values, you have to use C. You can use as many arguments as you want. So here I've got 5 numbers that I'm going to save. And so Control Enter. And we have 5 values here. Can you store a mix of types? Not in vectors. No, vectors are just for the same types. But a list can store a mix. Yes, a list can store a mix. That's what lists are for. But vectors, yeah, they're quite similar. But yeah. So here we have over here, we've got numbers, and so we've stored 5 numbers, and so this is the annotation for a vector, so it'll tell us it's a numerical vector. We have only stored numbers in here. It has 5 elements in it, so from 1 to 5, and the elements are 1, 2, 3, 5, 6, 2, 1, 7. Can arrays store different types? There isn't anything called an array in R. But I believe that vectors are implemented using C arrays, and they can't store different types. So that's why. Lists can store different types, vectors can't, and there aren't arrays. So in the following block, just practice writing some vectors. So you'll want to take this hash out and say, write some numbers in here and run the code. So say the value of some items you've recently purchased. So I'll just put lunch, I bought a coffee, I bought a new shirt, I bought a train ticket, I bought a dog, and I bought a new wallet. So these are, say, my purchases, the value of my purchases. Control Enter, and you can see that they're saved there. They're also numeric, 1 to 6, and there are the entries. So sometimes you'll want to get things out of vectors, So this is called indexing. So now there are a few different types of indexing we can use in vectors. And so the first is to use direct indexing. And so in order to take a number, we must use indexing. So we must know what position it's in. So they're indexed with square brackets like this. So we're going to say this code here says of our array numbers, take the first one. So you might note if you've done Python, it'll start with a 0, but in R we start with a 1. So the first one is 1. So this one will take the first one. We look over here. What's the first one? 5. Run the code, and there it is. Cool, and you can change that so you can take the 4th one. It'll give us an error, I think, if we take something that's out of range. So if we try and take the 20th one, there's only 5. It'll give us a problem. So here we have numbers 2 to 4. And so this is sort of sequential indexing. So it'll take the second to the fourth of our numbers. So we've got our numbers here. And we will go the second to the fourth. So it'll take the second, which is 6, the third, 2, and the fourth 1. So now just to practice some indexing, write some code that takes the first 5 purchases from your previously saved variable. So I've saved it here under my purchases, and see if you can write a little bit of code that does something similar to this, but takes the first to the 5th. Give you a minute or two to do that. And if you have any questions, otherwise, if you've successfully completed that, just, let me know in the chat so that I know sort of when to move on. Awesome. All right, cool. What if you exceed the indexing range? Try it. I think it'll give you an error, but yeah, give it a go. Always fun to make the code break. Just see what happens. That's how you learn. Cool. So this one here will just be my purchases. And then we want to go 1, 2, 5. And run that. And it'll give us the first one. It won't. Forgot what I bought there. I think it'll forget about my wallet. Cool. So now if we want to do logical indexing, means that we can obtain true or false values for every position in the vector. So it'll just do a comparison with every position in the vector, and it'll give us back a vector that contains Boolean values, right? So the following code will tell us which element in our numbers array is greater than 5. And so when we run this, we'll get a vector that contains Boolean values, and the Boolean values will be true if it's greater than 5 and false if it is less than 5. So when we run this, we'll get false, true, false, false, true. So 5 is greater than 5, 5 is not greater than 5, 6 is greater than 5, 2 is not, 1 is not, and 7 is, right? So if you look over here, you can see which of your recent purchases were greater than $10. So to sell, and then we can write some code in this cell that will let us figure out which one of those. And then I'm sure that you can fill it in and figure out. And so you run that, and then we can see that the first one was greater than $10, the second one wasn't. And we can use quite a few different operators here. So for example, if we want to check if we bought anything for $100, say my purchase is double equals $100, so that's equality comparison. Run that. The last one was, but the rest of them weren't. So if we're ready, we'll go on to the second half of the workshop, which we start talking about data in R. So sort of we'll be dealing with CSV values, and we'll start to use these concepts on things like spreadsheets or data frames, which if you've seen a spreadsheet, then you'll be able to see what a data frame is. Cool. So if we're ready to go on, we can start going on here. And so in R, we're going to be using, how can we run the entire file? Run down like this, run all. It'll run every bit of code that you have in the whole file. If you want to run an individual chunk, you just press this little button here. On it.
Or Command-Shift-Enter.
Command-Shift-Enter. Okay, Command-Shift-Enter is the shortcut to run a single chunk. Cool. Where is single equality used in R? So in some functions, when we want to specify what values it'll take, so sometimes you'll have default arguments and you'll have non-default arguments. So it's normally used to specify what the arguments are in a function. And this will be used for the arrow sign will be used for basically everything else. I'm not 100% sure exactly why that is. What is the difference? So I'm not exactly sure on all of it. I think that the arrow sign will first create the variable, then assign it, and the equals will just try and assign it. I might be wrong, but I know that if you regularly use interval equals, you sometimes get funny errors when you're using data frames. Is there a single parent library that encapsulates all the data science related libraries so that we can just import the single library instead? So there are lots of libraries for data science. So, I mean, if you were to encapsulate all of them, it would be like gigabytes of downloads. But there is an excellent one called tidyverse. So if you want to import tidyverse, that'll give you a lot of functionalities. And so, yeah, we'll be talking mostly about tidyverse this time. And so, yeah, tidyverse is excellent. Is the data set from a package or a CSV? I was wondering if I could download. So it's hosted on my GitHub. There's a link there, and you can just download it from there. Otherwise, afterwards, I can show you where I found it. I found it on a website called kaggle.com. There's heaps of good data there as well. So it's not from a package. Can I type the link? Sure. Well, the link's in the RMD file. The link's just here. If you go down a bit. The link's just here. Awesome. Brilliant. Okay, so let's go on to the tidy data section. So when dealing with data frames in R, we typically try and keep the data in a tidy format. So if anyone's done a database subject, you'll know this as Ted Codd's third normal form. If you've got no idea what that means, don't worry. So there are essentially 3 rules for tidy data. Each variable forms a column. So when we take measurements, every variable has its own column. Every observation will have its own row. And every observational unit forms its own table. So that means when we're measuring things, we want each row to come across as a measurement. We don't want anything in like squares or any funny things like that. It just makes the data a lot more easy to analyze, and a lot less things will go wrong if you have data in tidy format. And so that will essentially look like every column will just measure one thing. You don't have duplicates in those columns. You don't have lists in those columns. You just have a single number or a single variable. And so we're going to be using a collection. The packages we use are going to be from this collection called the tidyverse. It's well worth your time. It takes a lot longer than an hour to learn most of these packages, but if you want to learn them, it'll save you a lot of time if you're going to be dealing with data regularly. So we're going to install 2 packages now. What we want to do is to install the packages, we're going to run these 2 commands. So sometimes people will get problems here, but you want to just run it as if you've installed, as if any other line of code, where we just click Control Enter. And here I get a thing where it says that I've currently loaded the package. So I can't do it because it's currently loaded on my machine. But if I go onto my, I just go on the RStudio cloud, oops, that's not good. But you'll see this and it'll take about a minute, maybe, if you've got a slow internet connection, to install both of these. Otherwise, it should be perfectly fine. Just once you've managed to install them, let me know, because I know we have had some problems with people installing them in circumstances. So if you manage to install them all good, let me know. You'll know they're installed when a bunch of red text will fly up here, and then your blue thing will disappear, and then it'll reappear a bit later with something that says successfully installed. Oh, so once you've installed those packages, I just type in the chat quickly. Beautiful. Awesome. Cool. All right. So it seems like most people, well, a good amount of people have managed to install their packages, and we'll keep going. So in R, we're going to store these things called data frames, which are similar to vectors, but they're, so we can store them in a similar way to vectors. They'll come up here, but they'll store like something that looks similar to a single spreadsheet in Excel, so a single sheet in Excel. And R has many like fantastic functionalities that we can use to sort of sort, select, summarize, produce graphics, do statistical analysis and machine learning on these data frames. So they're really excellent. They're very fast. They can store a huge amount of data compared to Excel, which stores relatively small amounts of data. And so we'll start by reading in a CSV file that contains records of all of Melbourne's housing sales. And so we'll read that into a data frame. And so first we have to load the packages that we just installed. So run these 2 lines of code and you'll get that. And it will load them into your R. So you've installed them and now you'll like start them up. And so then we're going to read in the data using the function read_CSV. So it takes a CSV file. It can be from online, on your computer, or yeah, I think you can do it. This is for CSVs, but there are other read functions that let you do it on databases and stuff like that. So we're going to save. So this line of code here, it reads the CSV from this URL, and it takes that object and it puts it into our variable called housing data. So Control Enter, and it's going to read that. It's going to give us some red text here telling us about what it's just done. That's fine. That's not an error. That's just some information about what we've read. So now we've read it, and it should appear in here under data, housing data. It'll tell us it's 13,000 observations. So observations will be rows and variables will be columns because this is tidy data. So we've got that like that. And so if we want to see it, like how you might see sort of a spreadsheet or how you might see it in a table format, we can use the view function. So if we run this, it'll view it. And it'll view it over here like this in a separate tab. You know, 2 tabs here, our code and our data tab. And it'll tell us all of the sales for houses in Victoria in between 2016 and 2018. readr is a package that lets us do reading functions. If you're wondering what it is in here, this tells us that this function is in this package. So it tells us look in readr package and find the function read CSV. And so readr is just a package that lets us read these things in quite easily. And so we've got all of these suburbs, all of these entries, and we have a bunch of columns here, the seller, the date, the distance from the city, the postcode, all of these things. So we'll do more analysis on this data set in the next session. but we'll just set you up with some of the tools now that we're going to need for that. And so we'll be able to do some things with this data, like query it based on which suburb it is, which year it's, or not you, if it's sold for a certain amount. We'll be able to query dates, distances, things like that. So we'll be able to get information from this data that we otherwise, quite easily. So all that sort of information we'll be looking at. So I'm going to introduce you to something called the magritter pipe. And that is something that is quite unique to R. So this might be a bit confusing if you've never used it before in R. But essentially what it does is it passes our arguments along. So it allows us to do multiple functions in one line. It takes the previous variable and puts it into the first argument in the next function. For example, it takes 16 and it puts it into log base 2. So it'll take 16 and it'll put it into log base 2, which will be 4. It'll take that 4 then and pipe it along into this sum function, which adds all its arguments together. It'll make that into 9. It'll evaluate that as 9. And then it'll pipe it into here, and it'll take the square root of that. So it lets us do them in this sequential order. So these functions, it'll let us write it out nicely like that. So then if we want to do something to the 3, then we can just write another pipe and tell it to do that. So if we run this line here by highlighting it, Control Enter, we'll see that it returns our 3. So it'll bump it along like this. And then if we take out the square root here, we'll see it stops at 9. There you go. So it's exactly the same as this, but it just looks a lot nicer. It's the logs, so it'll take that, it'll evaluate it, and then it'll put it in this argument here with 3 and 2, which sums them all together, and then it takes the square root of all of that. So this does the same thing. It looks a lot better, and when we're doing it on data frames, it'll help us a lot. It'll say first do this, then say do this, and do this, and we can just keep adding more pipes on it. So it might seem quite trivial when we're just doing it for integers here, but when we're working with entire data frames or big vectors, it's a lot more useful because we can see exactly what's happening and we don't get this kind of ugly stuff where we got a bunch of brackets and numbers randomly and stuff like that. Cool. So we're going to do some simple data manipulation. So if you've loaded in the libraries, we're going to need dplyr for this. So the first verb that we're going to go into is filter. And filter is a verb that lets us filter rows that satisfy a certain constraint. It allows us to see subsets of the data that we're interested in. So arrange then sorts the rows by the column that's specified in the arguments. Descend means it's descending. So note in this example, we first select, then use the magritter pipe to pass it on to a range, and then it will automatically, that'll automatically arrange it. So it'll automatically take housing data, it'll filter it where the suburb is Caulfield. So we're recording this in Caulfield, and then it'll arrange the house sales descending by the price. So if we've got this here and we run this here, we will see it'll run that and it'll give us this output here. So it'll take our housing data, it'll find only the rows that are in Caulfield, and then it'll arrange them and it'll do descending order of the price. So these ones here are the most expensive houses in Caulfield that have sold in the past, in the time that the data frame was. So we'll see that this is the most expensive. It has 5 rooms. It's a house. It's sold by Gary. I think that's a real estate agent. And so it's got all of these features here. So to practice doing some data frame manipulation, there's just a couple more things left. And so what is that. So that's the magritter pipe character. So that essentially means take housing data and put it into the filter function. So code that looks like this is exactly the same. Sorry, so if we go back here, this code here says take 16, put it into log2, put it into sum, and put it into square root. And so this will take this and then do this exactly, and then do that in the sum, and then do the square root. So that just means take this and then do it to this, and then do this, and then do this. So this one, if you read it here, take the housing data and then filter when the suburb's core field, and then arrange it in descending order of price. So to practice this, you can copy these entire rows and use it as a basis for the next few questions. But to practice this, just write these out here, and you'll be able to find the highest price in your suburb, what's the house with the most bedrooms, and you can do it, and then you can filter it once and you can filter it again. So you can filter it so that the suburb is core field, and then you can filter it again so that, say, the bedroom 2 is what it's saved under, is greater than, say, 3 or something, and then you can arrange it by descending in order of bedroom 2, for example. So you can sort of chain these commands together. So you can say housing data and then filter it for this, and then filter it this, and then filter it for this. So you can use this and write out these. So I'll give you a few minutes to just write these out. And then, yeah, we've got a couple more things left. Actually, I think then that might be the end. So once you've done these, just let me know. And we've got a bunch more on tomorrow. So I think there's a question I missed here. How do you use max, min, standard deviation functions with data frames? So if you want to get a single row out of the data frame, I'll just show you how to do that here. So one way you can do it is you can do summary. Like that, run that line, and it'll print here all of them. So it'll do it to every single row, so 21 rows. So that took a little while on my poor computer, but it'll say, okay, property count, I don't know what that means. Longitude, region name, I don't know what those two are. But for example, we've got year built. It says the earliest one is in 1196, I don't believe that. And the latest one is in 2018, and it's got all of these functions. If you want to do things like custom functions for standard deviations, we can get out a single thing. So yeah, I'm going to write housing data. And now this is a $sign operator, and that'll let us get the vector that corresponds to this entry. So remember how we said that vectors only had the same type? These rows down here, they are vectors. So each of these is a vector. So if I wanted to get the rooms vector, which is a vector that's 13,000 entries long, then what I can do is I can write housing data, and I want to get the rooms vector. So I write housing data, $sign, rooms vector. So that's rooms, and this will be a vector here. So this will be a huge vector, and then we can use the SD function on that. And if we execute this, it'll give us the standard deviation of rooms. And so you can use that on price, you can use that on anything numeric. It'll give you an error if you try and use it on something like, say, date or council area. Cool, so I hope that one helps. What is the ascend function called? It sorts by ascending in default. So if you don't put the descend function on, it'll automatically sort by ascension. Okay, so this works with one package. This will work for all packages. sorry. Okay, so the magritter pipe works in tidyverse packages. A lot of packages use it. So, but it doesn't work in base R. If you want to just use it by itself, you use the magritter package. But any tidyverse package will use it, and a lot of other packages will use it. Yeah, and it wouldn't surprise me if they put it in base R in the future. It's part of dplyr. Yeah, it's part of dplyr. It's part of lots of things. So column names are name vectors. Yeah, so yeah, they're like that. Can we build a custom function? Yes, you can. I'll show you that. Can you build a custom function? Yep. So if you want to build a custom function, so I'll just add the mean and the median together, I guess. So you write so that's mean median, which is what my function is called. I'll add the arrow indicator. Oh, gosh, sorry. Add that, and then you write function. Write in what the arguments are. So this will be a vector, so we'll call it my vector. Then you write curly brackets, and you say, and you don't need a return statement. The last thing at the bottom will be the return. So you go mean vector plus standard deviation. Sorry, this needs to be wrapped in. Code. And so then this will just return it. So we can run this. And then if we run it on, say, our housing data, rooms, it'll give us the mean plus the standard deviation for that vector. Is there anything similar to a dot index function? I actually don't know what the dot index function is. Is there any way to ignore cells that have no data? Yes, that'll come up in the next lecture. Sorry, have I given you an example that has, yes, so you can filter. So you'll be able to use filter, control filter, and then .na, and then we're going to put our column name. So just do this and then write your column name in here. So that'll remove NAs for you. There's another way to do it, but are we receiving another email? Yes. So you should receive an email. I'll paste a link at the end. Daniel, are you right to do that? Just paste a link. Cool. So you can ignore that. Yep, that's that. Is there a way to slice the data frame so it only sorts the first 5 rows? Yes, there is. That is called, I'll run through that quickly next time as well, but that's called select. And then you just write the column names that you want. So you'll just write the columns that you do. So you pipe it into this and it'll select for the column names you want. Okay, cool. Thank you. NA equals true. I don't know if that will work, but yeah. Cool. Beautiful. Which head will show? Yes, there is head. Yeah. Cool. Is there a function like head? Yes, there is a function, and that will be you'll pipe it into this, and then you write the number that you want. So if you want the first 10, you write the first 10. This will be your data frame. Awesome. So it's
I might go over the
cool. Yeah. So it's 5 minutes to 3. So we'll have Daniel here. He's our event officer he does the events. And so he'll tell us about some of the upcoming events that are coming for the Monash Data Science Society quickly. And then we'll do the final bits of questions, and we'll send you sign-up links for the rest of our events. But yeah, cool. So that's the end of the lesson. But yeah, thank you so much for coming, everyone. I hope you learned a little bit. Yeah, I'll write that in there. Cool. All right, cool. Thanks.
Cool. Thank you so much, Josh. That was fantastic. And thank you everyone for coming. What a great turnout. 42 people. That's way more than we ever expected. So that's great. We have a couple of events coming up in the few coming weeks. We've got tomorrow's session, and if you've already signed up, then we have workshop 2 for a bit more of an advanced stream, which Josh, you're hosting again, I think. Is that right?
Yeah, so tomorrow just builds on today. Basically, yeah, if you know some of the basics, it'll be good. And this is about as much as you need to know. So please come tomorrow if you're free. It'll be awesome to see some of you guys there as well. Yeah.
Yeah, and we got another event. So that's on Facebook as well. So you can go check that out on our Facebook page. This Friday, we have a careers sort of panel event with a consultant from Monash Talent. So you can sort of learn a bit more about what it takes and what to expect when applying for jobs at the end of your data science course. What else do we have? We've got we're running a little mini datathon in a week's time at the end of week 2, which will be a competition between individuals or teams to analyze the data set that Varun, our vice president, has put together. There are cash prizes and a careers consulting prize as well for the winners. So look forward to that. And then there are whispers of a drinks night coming up in week 3. So watch this space. We're going to do something a bit more fun, a bit more social. So I look forward to that. But to keep track of all of our events, make sure you go to our Facebook page, MDSS, or Monash Data Science Society, where we post about everything we're doing. So go follow us, and yeah, I think that's it. I think that's time for today. So thank you all for coming. If you'd like, we'd like to take a sort of screenshot with all your faces. If you'd like to put your cams on, and just share it for our socials and show what we're doing. If you'd like. Yeah, cool. Oh my God, this is great.
We'll put the link for the recording into the Google Drive.
Yes, yeah.
Just where you got those R things, and we'll share that again.
And we'll put that in the we'll post that on the event as well. Yeah. Awesome. All right, I'm gonna do it in 3, 2, 1. Awesome. Sweet.
Beautiful. Awesome. Cool. What a success. Yeah.
All right, guys. Thanks so much. Look forward to seeing you on campus. And yeah.